Now let's take a look at what's going on with what that router is doing and why it's doing it. So if I just grab the IP addresses that are affiliated with the router, what we're going to find out is that on the left-hand side of the router, the 192.168.104.1 address is on a unique IP network from the outside of our router, which has an IP address of 203.0.113.8. These are going to be on two unique IP networks. And the job of the router is to get traffic from one IP network to another IP network. So it kind of creates this separation of networks. So routers separate different unique IP networks, which means that routers are a layer 3 device at the network layer. We'll come back to that more later. In fact, you probably will get tired of hearing me talk about layer 2 and layer 3 at some point in the series, but that's okay. If you're currently working in IT networking, you'll realize that people talk like that all the time. If you are not working in IT and you're trying to get your career boosted, you should get your mind thinking about layer 2 and layer 3 constantly. Remember, I just told you layer 2 was the frame, the MAC address, network interface cards. Here at the network layer, we're talking about IP addresses and routers. So let's look at how this address with a combination of this subnet mask work together. Now, you're going to get so much information about how this works in the next course in this series. It might make your brain a little numb. That's okay. What I want to look at here is the basics of this. What our subnet mask does is it separates our IP address into two portions. It separates it into a network portion and a host portion. The area on the left is the network portion. The area on the right is the host portion. Because it is a mask, what we do with that is we take the area that represents the network portion, the 255, 255, 255 in the mask, and we just mask off that area of our IP address. Same thing with the host portion. Where there's a 0 there, that's our host portion, and we just mask that up and cover up our address so that we can see the dividing line between our network portion of the address and our host portion of the address. Network portion and host portion here are very much akin to your home address. If you live at 123 Main Street in Cityville, Illinois, with a zip code of 60002, the idea there is 123 Main Street, that's your house address, that's your host. The zip code 60002, that's the general area you live in, and there's a whole bunch of houses with different addresses in that area. Our network portion of our address represents a group of devices. The host portion represents an individual device in that bigger group. When we apply this to our circumstances here, and we separate out the host portion of these addresses, what we're going to see is that the network portion of each of these addresses is unique. So 192.168.104 is unique from 203.0.113. What that means is that these two IP addresses are in two separate networks. Now that we know these are on two different unique IP networks, let's look at some of the rules and the behavior that we're going to expect to see on a network with addresses like this. So let me remove the router, and instead of the router, we're going to take a diversion for a second, and I'm going to set up a small lab here and put two PCs in my lab. I'm going to connect them together with a Ethernet crossover cable so they can have direct communication to each other. They're not connected to the internet. They can only send messages back and forth to each other. One of the rules here of IP addresses is that if I give my machine on the left the 192.168.104.1 with a mask of 255, 255, 255.0, and I give the IP address of the machine on the right to be 203.0.113.8 with a mask of 255, 255, 255.0, these devices are on separate networks. When I try to send that message, what we'll find out is that since these devices are on different networks, my workstation on the left won't even send the message because it has no place to send it to. So it's going to throw that message away before we even get it over to our destination. Now, as a quick side note, you might be wondering why in that 203.0.113.8 I have 3 zeros in there. Well, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, those are all worth the same thing. It's all worth 0. The only reason I put those 3 zeros there was to keep the numbers nice and aligned for us there, to make it easy to see the distinction between our network and our host portion. Now, how do we solve this problem? If I want the machine on the left to talk to the machine on the right, what do? Well, I add a router. Once I add a router in there, the router's job is to take traffic that is on one unique IP network and forward it on to a different unique IP network. That is the job of the router. So in order to communicate from a unique IP network to another unique IP network, we have to have this intermediary device connected into our system to allow that traffic to pass. Now, we can fix this problem if we do actually want the PC on the left to talk to the PC on the right. We just have to change one of the IP addresses such that it's on the same network as the other device. So if I change the machine on the right to be 192.168.104.2, now both of these machines belong to the same IP network, 192.168.104, and now it's completely okay for the machine on the left to send a message to the machine on the right. The message will successfully transfer and will be in good shape. These couple little examples, these are really the fundamental rules of IP addressing and how we can pass traffic. If we have two devices that are connected together with a cable, they're on the same local network, the IP addresses must also be on the same IP network. If they are not, we will not be allowed to communicate. Hopefully, I will drill this into your brains over the next upcoming many hours of courses so that we don't make simple mistakes of trying to have two devices on the same local network with two different unique global IP addresses. That just won't work.